Imagine you're Sleeping Beauty, about to enter an experiment. You'll be put to sleep on Sunday, after which experimenters will flip a fair coin. On Monday, they wake you up and ask you this question. What do you think is the probability that the coin came up heads? Or another way of phrasing the question might be, how confident are you that the coin came up heads? Then, after giving your answer, they give you a drug that puts you back to sleep and causes you to forget that you were woken up. Now, if the coin came up heads, the experiment ends. But if the coin came up tails, they wake you up again on Tuesday and ask you the same question. What do you think the probability is that the coin came up heads? After you answer, they put you back to sleep with the same memory-erasing drug. So if the coin came up heads, you're asked the question once only on Monday. But if the coin came up tails, they ask you on both Monday and Tuesday. But on Tuesday, you have no memory of being asked on Monday because of the drug you were given. Waking up on Tuesday feels the same as Monday, so you don't know which day it is when you're woken. You know all this in advance. Before the experiment begins, it's been explained to you like I just did about how it will all work. So when you're woken up, the only things you won't know are what the coin flip result was and which day it is. Now, if you were asked before this experiment what the probability that the coin comes up heads is, you would obviously think it's 50%. But when the experiment starts, you go to sleep and then wake up in the experiment. Should you change your answer or still say 50%? Take a moment to think about it and pause the video if you like. People disagree over what answer you, Sleeping Beauty, should give. Some think you should answer 1/2, and we call those people halfers. The others think you should answer 1/3, and we call those people thirders. Which one is right? I actually think they're both right, because I think they interpret the question differently and so are answering different questions. I'll explain this in detail later, but first, let's look at the reasons why someone might be inclined towards each of these answers. Here's what the halfers might say. The probability that the coin came up heads is 1/2. Before you were put to sleep, you knew the coin toss was fair, and at that moment you believed it was 1/2. You also knew that you would wake up and find yourself in exactly the position you find yourself now. You haven't learned anything new, so you have no reason to change your opinion. You should still think the probability that the coin came up heads is 1/2. This answer depends on Bas van Frassen's reflection principle. Basically, if you know that at a later time you're going to think the probability of some event is going to be X, you should believe right now that the probability will be X. But if we listen to the thirders and agree that the probability is 1/2 before the coin toss, and then 1/3 after we've been woken, then we've violated this principle. Here's what the thirders might say. It's true that before the experiment starts, we should think the probability is 1/2. But when we are woken, we should think it's 1/3. Imagine, for example, that we run this experiment 1,000 times. If we did that, then roughly 500 of these experiments would be ones where the coin came up tails, and the rest, another roughly 500 experiments, would be ones where the coin came up heads. Each time the coin comes up tails, we have 2 awakenings, one on Monday and one on Tuesday. But each time the coin comes up heads, we only get 1 awakening on Monday. So only around 1/3 of all awakenings are heads awakenings. That is, roughly 500 of the 1,500 awakenings are heads awakenings. You should believe that the probability the coin came up heads is 1/3. I've given a rough outline of each position, and I would love to know which of these 2 arguments, if any, you found more compelling at this point. Perhaps I'll have changed your view by the end of the video, but it would be interesting to hear which of these positions sounded more plausible at this point. Remember, there are very intelligent people who argue for each position. Let's look at these 2 options in a different way that will start to give you an idea of why both answers are right. Let's consider the expected frequencies if we were to run this experiment many times and see how each position can be argued based upon looking at those frequencies. Halfer. Run this experiment 1,000 times and about half will be heads experiments. The answer is still 1/2. Thirders. Run this experiment 1,000 times and about 1/3 of the awakenings will be heads awakenings. The answer is now 1/3. Notice when I present things this way, it looks like both are saying true things, but they're also talking about different things. The experiment is the whole setup, including tossing the coin, putting you to sleep, and then waking you up either once or twice. Approximately half of those experiments will be ones where the coin came up heads. But if we talk about awakenings within each experiment, well, there's more awakenings than there are experiments. In about 1,000 experiments, there will be roughly 1,500 awakenings, only 1/3 of which are awakenings where the coin came up heads. What is the right answer? Well, when asked, what do you think the probability is the coin came up heads? Both are correct answers to different interpretations of that question. One about the probability that this is a heads experiment, and the other about the probability that this is a heads awakening. In order to justify my claim, I'm going to need to ask you to accept another controversial claim first, that there are no unconditional probabilities. I'll explain what that means now, and if we accept that as true, then what we find is that each of the halfers and thirders are correct answers to different conditional probability questions. We have a question before us. What do we think is the probability that the coin came up heads? When writing this down formally, we might write it down as P of A, meaning the probability of A, where A is the claim the coin came up heads. This is the unconditional probability because we are not saying the probability of A given something else, such as that I was just woken up, or that the coin has a head on each side, or that it's a fair toss and so on. This is just the probability of the event A with no further context, no condition. Conditional probabilities, on the other hand, do talk about the probability of A given B. For example, the probability of drawing the ace of spades, A, given a standard deck of cards and a random selection, B, is 1 in 52. Probability of A given B is 1 in 52. However, the probability of drawing the ace of spades given a deck that contains all and only the spades cards, C, would be 1 in 13. Probability of A given C is 1 in 13. What about the unconditional probability of drawing the ace of spades? Should we be thinking about a standard deck, a modified deck, some other deck, or not even a deck, but just picking random objects out of a box, one of which just happens to be a card and is the ace of spades? This is the reference class problem. There are many different reference classes, such as a standard deck, modified deck, our random box of goodies, and so on, and no way to pick one over the other to answer the unconditional probability of drawing the ace of spades. What is the unconditional probability of drawing the ace of spades? That is, I think, a meaningless question and therefore has no answer. This is a controversial claim to insist that unconditional probability is a meaningless notion. There are only conditional probabilities, and any time we see a probability that looks unconditional, it is only because the conditions are assumed. Like when I ask you the probability of drawing the ace of spades, you assume I'm talking about a random draw from a standard deck. I don't need to explicitly tell you that, but it's there in the background. Let me explain this by analogy with the word need. We might say things like, I need food, I need to get to work early, I need a holiday. Now we might think all these things are true, but they aren't true as universal or pure unconditional claims. I don't just need food, but I need food relative to some goal or ambition. I need food to live, to stop feeling hungry, to maintain energy. If living isn't a goal or ambition, then food isn't needed. I need to get to work early to perform my job satisfactorily, so I can remain employed. I need a holiday, not just as a raw claim, but so that I can be well rested and keep myself happy. There is not just a need, but rather a need is relative to some goal or objective. But most of the time we don't need to explain that. When I say I need a holiday, people understand that I mean, I'm tired, I need a break from work to get my energy back and keep my motivation levels up. The need is relative to or conditional on something else. But that doesn't need to be specified every time I say I need such and such. It's assumed that it's there in the background. Everyone understands what I mean. When we say the probability that a coin comes up heads is 50%, we're not saying that as some universal truth. Instead, we're assuming a whole lot of background things about physics and fairness and intentions of the coin flippers and so on. It's a probability relative to or conditional on a lot of background information. It's just that we don't need to mention it most of the time because we understand that it's there in the background. We're all familiar with it. It's the same with Sleeping Beauty. There's no unconditional probability the coin came up heads. Instead, it's all relative to or conditional on something. The probability the coin came up heads given the experiment is 1 in 2. The probability that this is a heads awakening given that I've been woken up is 1 in 3. All probabilities are conditional, And when we talk this way, we make that very clear. And so both the halfers and the thirders are right, because they give the probability for different conditions. The halfers are interpreting this to be a question about experiments. And out of 1,000 experiments, around half will be experiments where the coin came up heads. The expected frequency of heads in the set of experiments is around 1 in 2. The probability of heads conditional on experiments is 1 in 2. The thirders are interpreting this to be a question about awakenings, and out of 1,500 awakenings, around 1/3 will be awakenings where the coin came up heads. The expected frequency of heads in the set of awakenings is around 1/3. The probability of heads conditional on awakenings is 1 in 3. And the unconditional probability of heads? To that question there is no answer. It is a meaningless, nonsensical question akin to saying, "I need a stick," while insisting that there is nothing more to the story, nothing to say about why I need a stick, no matter how much someone presses me to answer about why, no plan to use it for anything. It's just true, I insist, that I need a stick. I'd be making no sense, and my claim would be nonsense. It's time to put this into practice with some good old-fashioned bets. Let's consider the question we're being asked again with fresh eyes. We're woken up, and the experimenters ask us what we think the probability is that the coin came up heads. What do they mean? It's hard to know what they're really asking without further clarification, and there's no way to answer wrong because there's nothing at stake. We could give any answer we like and it wouldn't matter. Probability, as I see it, is a guide to life. To put it very simply, it is a tool we use to evaluate the world around us and draw conclusions about the best way we should act. It's not the only thing we use. For example, we also need to take into consideration the consequences of taking the wrong action. So let's put some money where our mouth is and see what happens when we're offered some bets in the experiment. First bet we're offered. Before the experiment starts, we're asked to guess what the coin result will be. If at the end of the experiment the answer we gave at the start was right, we win $100, and we lose nothing if we're wrong. What should we pick? Well, as we all know, around half the experiments will be heads ones and half tails. Really doesn't matter what we pick, we should just be sure to pick something. You've got to be in it to win it. Second bet. Every awakening we're asked what we think the coin came up as. If we answer right, we get $100 and lose nothing if we're wrong. Well, if we run the experiment many times, around 2/3 of the times we're asked that question, tails will be the winning answer. We should pick tails. Third bet. Before the experiment starts, we get to write heads or tails on a piece of paper. When we are woken up, we can show it to the experimenters as our answer when they ask us the question. At the end of the experiment, if we showed the experimenters the guess we wrote down and we were right, we win $100 and lose nothing if we're wrong. In this bet, it doesn't matter what we write, since we can only win once per experiment, so we should just be sure we pick something and show it when we wake up. Doesn't matter which, since heads and tails are equally likely. We can continue on like this, inventing more and more bets where choosing tails is the winning move, some where heads is the best choice, and more where either choice is fine. In all cases, which answer is best depends on the exact setup of the experiment and those points where we have something to gain or lose. There's no unconditional probability that some fixed answer. Instead, there are only probabilities relative to the circumstances. I've explained why I think intelligent people disagree about what the right answer is. They're searching for some unconditional probability of A, and they think the real problem to be solved with this Sleeping Beauty puzzle is how to work out that unconditional probability. I've outlined why I think the quest is impossible, and in fact all they have done is to each identify the correct answer to different probability questions. The problem here with Sleeping Beauty is about different interpretations of the implied question, rather than any genuine paradox or deeper puzzle. My own opinion is that an unreasonable amount of philosophical disputes come down to mere differences in interpreting words or sentences, semantic disagreements, though that's a topic for a different video. Probability is a complex and controversial topic, like all interesting philosophy problems are. If the answer were easy, it wouldn't be a good philosophical topic, and probability is an area of great interest to me, one where I have some big unanswered questions, particularly as it relates to fine-tuning arguments for God's existence. That's a topic I plan to cover in other videos later. All this is to say that while I think the answer I've given here is a satisfying resolution to the problem, There are always going to be disagreements, and I'm sure that not everyone is going to be convinced.